What's up, my chem peeps? Who is ready to compare my Q to my K? Okay? For a synthesis of ammonia from its elements at 500 degrees Celsius, the equilibrium constant K is 6.0 times 10 to the minus 2. Predict the direction in which the reaction will shift towards products or reactants to reach equilibrium in each of the following cases. First thing I need to do is write out a balanced chemical equation so I can come up with my reaction quotient. We're going to start here with N2 gas plus H2 gas forming NH3 gas. Let's balance. 2, 3, balanced. All right, now that we have a balanced chemical equation, so let's write an expression for our reaction quotient Q. Defined the same way as K, we're looking at the concentration of our products, NH3 in this case, raised to the coefficient in the balanced chemical equation 2 over concentration of our products, nitrogen times the concentration of hydrogen, raised to its stoichiometric coefficient of 3. All right, so all this worked and we haven't even begun. We're now given a set of conditions that may or may not be at equilibrium. Let's plug them into our reaction quotient to find out. So our first set of conditions, 1.0 times 10 to the minus 3 squared over 1.0 times 10 to the minus 5 times 2.0 times 10 to the minus 3 cubed. Boop. Calculator time. Parentheses 1.0 second E, negative 3, close parentheses, squared, enter. Divided by parentheses 1.0 second E, negative 5, close parentheses, enter. Divided by new parentheses 2.0 second E, negative 3, close parentheses, cubed, enter. So my Q value under these conditions is 1.25 times 10 to the 7. So a very large number. Now we need to predict the direction. We always want to compare Q to K in alphabetical order. My K value is 6.0 times 10 to the minus 2. That is my K value. I'm comparing that to my Q value of 1.25 times 10 to the 7th. Again, I'm doing it in alpha order, K compared to Q. In this case, K is less than Q. So under these conditions, in order to establish equilibrium, my reaction is going to shift to the reactant or left side. I'm just going to follow that little caret and the arrow that it points. Reactant side. Right, let's do it again. A new set of conditions here. Q is defined the exact same way. We're just given some different concentrations. So Q is equal to 2.0 times 10 to the minus 4 squared divided by 1.50 times 10 to the minus 5, close parentheses, times 3.54 times 10 to the minus 1, close parentheses, cubed. Calculator time. Parentheses 2.0 second E, negative 4, close parentheses, squared, enter. Divided by new parentheses 1.50 second E, negative 5, close parentheses, enter. Divided by new parentheses 3.54 second E, negative 1, close parentheses, cubed, enter. Answer to 2 sig figs here is going to be 6.0 times 10 to the minus 2. Let's compare Q to K in alphabetical order. K is equal to 6.0 times 10 to the minus 2. Boom. That's my K value. Comparing that to Q, 6.0 times 10 to the minus 2. That's my Q value. Again, alphabetically, K compared to Q. How do these two compare? They are equal. So guess what? We are actually already at equilibrium. There is going to be no shift. All right, and then last set of conditions. Again, our definition of Q remains the same. We just have some new concentrations. Q is equal to 1.0 times 10 to the minus 4 squared over 5.0 times 1.0 times 10 to the minus 2 cubed. Let's calculator it up. Parentheses 1.0 second E, negative 4, close parentheses, squared, enter. Divided by 5, enter. Divided by parentheses 1.0 second E, minus 2, close parentheses, cubing it. Boom! Two significant figures, we get 2.0 times 10 to the minus 3. Let's compare K to Q. My equilibrium constant is 6.0 times 10 to the minus 2. That's my K value. My Q value, 2.0 times 10 to the minus 3. It's my Q, my reaction quotient. Compare alphabetically. Always put the K first, then the Q. In this case, K is greater than Q. So as I think about which direction my reaction is going to shift, think about the direction in which that little caret is pointing. It's pointing to the product side. So we're going to form more ammonia. Boom! We are done.